Hi, welcome back to my channel. Well, in this video, I will show a demonstration regarding a very important statistical package, which is open source, and that is known as JASP, which is actually named after a very famous Bayesian pioneer, that is Harold Jeffery. And this JASP full form is Jeffery's Amazing Statistics Program, and it is made by the University of Amsterdam. I'll be sharing a link of this from which you can download on my description box below in this video. And this is an open source, and good thing is that it is very user friendly. So how to execute, how to perform the analysis, I will start. Since this channel is usually made for the students or the researchers who are doing their study or who are doing their research in agricultural universities, which includes agricultural sciences, allied sciences, forestry. So I'll be starting with the basic experimental design, that is one-way analysis of variance or CRD, and meanwhile we can also perform the descriptive statistics also. So for that I have already a CSV file available on my desktop. So how to import the data set? Here I have to click on this menu, then I will go to this open, then after that I will go to this computer. Since my data file is on desktop, I'll click on this desktop. Make sure your Excel file, you have a CSV file here, then comma separated file value, we can say we will import this data, that is CRD file. Click on this open, then this data will get imported. So we have two columns, treatments and contamination. So I have 22 treatments, and I have a contamination variable of interest, so continuous variable. So I want to evaluate all these 22 treatments based on this contamination. So we have a lot of options here: descriptive, t-test, analysis of variance, mixed models, regression, frequencies, factor. We can say the data reduction techniques. And the important thing here is that we have machine learning options also here. We can perform regression or classification problems. So this will be my first video. I will start with the basic CRD, because all the summary statistics and t-test, this can be done with the simple MS Excel, or you don't need any kind of sophisticated softwares for that. So I will directly using the analysis of variance, because this data set pertains to CRD. Let us start and click on this. Here we have a lot of options. In classic we have ANOVA, repeated MANOVA, or we can say repeated measures, analysis of variance, analysis of covariance, MANCOVA. Then in Bayesian we have also these three options. So we will click directly on this ANOVA. Then here what we have to do, automatically this thing gets popped up, this ANOVA table, and what we have to make the adjustments. So our dependent variable is contamination. I will click on this arrow, then I will click on this treatment and put that in here by means of clicking on this arrow. Then within few seconds, within fraction of seconds, our ANOVA table gets popped up here. So we have two sources of variation. One is due to treatment, because it's a clear case of completely randomized design. We have errors here because 22 treatments, 22 minus 1 is 21, and here we have three replications for every treatment. That means we have 66 observations, that is 66 minus 22 is 44. And here, based on p-value, all these 21 treatments are significantly different from each other. Within this click, we can display the descriptive statistics of each and every, where we can have the total number of observations, mean, standard deviation, standard error, and coefficient of variance. And we can get the effective size based on neta square, partial, or omega square. Also you can find out these values also. And here, if we are interested to check the homogeneity of variances, I will click on the homogeneity tests. So this Levin's test will get popped up, and here you can see that we have a non-significant p-value, so there's an existence of homogeneity of variance. Then we can also click on this QQ plot, and we will get a QQ plot also here. You can see, so majority of the observations are on this red line. So there's a normality of errors across these. Then post hoc analysis comparison is very important, because this thing only tells us whether all these, at least one of the treatment is significantly different from each other. Then we have to do a post operation, I can say a post hoc analysis, or we can go at Tukey's or Dennett stats. Let us go for this standard Duncan's range test. Click on this. Then for that I have to first click this, put these treatments here, and click on this. We will get these values here. Click, then click on this and flag this, and these things will get reflected because it is buffering here. So we have a post hoc comparison where you can compare each and every treatment with respect to the value that is the standard t value, because the comparisons are usually done on this t test. We can find out whether this treatment T1 is different from T10, from 11, from 12, from 13, from 14. We have mean differences, we have lower and upper confidence interval, we have standard error. And the good thing about this is that we have also got these comparisons, we have got p-values, we have got Bonfrings and Holmes, and we have got all these things, a good amount of statistical details. So you can see within few clicks how much of things, how much of information you can get from this JASP software. So this is a very user-friendly software, and I prefer and I'm recommending this to each and every student, especially student fraternity, because they used to get wondered here and there about your data analysis. If you are want to perform your analysis, especially you are having a CRD design, so what you have to do, simply you have to import the data by means of this. You click on this, then see where your file is, if and make sure your file is in CSV form. Then simply 2 clicks you will get the ANOVA. 1, 2, 3, 4, 5 clicks only, you will get this amount of bulk amount of information. So this is a very wonderful statistical software. So in the next video, I'll be making a next video on another design, because this was on CRD. I'll move to the this two-way ANOVA. This was the case of one-way ANOVA. And after that, I'll be making a video on factorial, then regression analysis. After that, on machine learning. The how to download, the link for this download option will be posted on the comment section below. Hope you will like this video. If you have any questions or comment, please, or any suggestion, please post on the comment section below. Thank you very much.